So we're going to go ahead and finish up these shafts here, and this was subject of a previous video, part of some of my CNC training over there on our Miltronics CNC lathe. This was a really good practice session for me, learning how to machine a part like this, and I have been enjoying learning how to use the Miltronics conversational programming, to be able to do a part like this. So now we've got our program saved over there. So if these guys decide that they do want some more of these shafts made, which they said that they had interest in making up another batch of them to keep on their shelf as a spare part, they'll let me know, and we may make up a few more of them. So we've got the helical gear and then a couple of the straight two, so 4 and 2. So I've already mic'd them to verify them, but I made sure. What I did is I machined these for a 1/2 thousandths interference fit over the gear there, okay? So not a lot. And what I need to do is we've got our 5mm keys here that we need to knock in there. They're kind of snug in the keys, so we need to get those pressed in. And to warm these up, I decided I'm going to use the heated oil method to install these, or attempt it anyway. So I brought my old 2-burner stove in here. We got a cast iron pot, and I've got some vegetable oil that will warm up and get it to around 300 or so degrees, 350 range. We'll have these sitting down in there, so it should evenly warm all of these gears here. And my hopes is that they expand enough so that we can, what we'll do is we'll just set the shaft. We'll set one of these in the Wilton vise right there, have it ready to go. And once these guys are to temperature, we should be able to pull one out of the oil, and hopefully it will. Can't get that to stand up there, but hopefully it'll just slide right on there, right into place. Now, if for some reason I can't get it to go on, it gets stuck and just won't go on there, I do have my small Famco arbor press right there that we can use to press them on there as well. I wanted to try the sweat method instead of pressing it, to try to eliminate the possibility of any kind of galling or even just shaving a little metal as it's being pressed on there. So we'll give this a try. This is a technique that my dad and I used for a few jobs back in the day, where we had some bushings, like a factory made bushing that needed to be installed in a piece of equipment that we were repairing. And the heated oil method is what they wanted us to use. It was the manufacturer's recommendation to do that, and it worked really well. So maybe it'll work for this guy too. We'll see. But let's go ahead and get these guys finished up. Once we get the gear sweated on there and shrunk into place, we'll set it up in the milling machine, and we've got a couple of set screws. I want to line up the set screw holes and just dimple the shaft to so that the set screws actually lock it into position. Same thing for the spur gear there. No keyway on the spur gear, but it does have a set screw. So we'll make sure we dimple the shaft to keep them locked into place. So let's see if we can get these guys finished up. Go ahead and get our gears down in the pot here. And I thought I had some smooth jaw pliers, but all I've got on hand are these right there. So we'll just use that to very gently pick it up without marring the gear teeth. And I'll set it down, and I'll use my hand with a glove to try to get them on the shaft. There's our other two. Spread them out a little bit, get some room. Just some inexpensive vegetable oil. Now I won't run this thing on hot. I'm going to turn it down to sort of like a medium low temp and let it get up slowly. I got one of my meat thermometers here that we'll use to check the oil temp as it starts getting hot. Let's give it another check, see about where we've been warming it for, I don't know, maybe about 10 minutes. Looks like we're around 290, almost 300 degrees. So we're right at our minimum temperature that we probably want to be at for doing things like this. I don't have an exact figure to share, but I'd say somewhere in the neighborhood of 300 to 500 degrees for warming up steel parts like this. A bearing would be different. But I think the 350, 400 degrees should put it in the neighborhood for enough growth there for it to go on there, especially with a 1/1000. So it also depends on how much interference you give something. 1/1000 on ours, I'm hoping that it just drops right on there, but we're about to find out. Yep, just hit 350 right there. All right, I'm gonna let these soak for just a little bit longer. And when I bring you guys back, we're going to see if we can drop one of these on the shaft. All right, let's give it a shot, see if we can get one on there. I didn't get the key lined up. That's what I did. It's trying to go on there, but I didn't get the key. I did not get the key lined up, so I'm going to put this one back in there and try this again. That was my fault for not lining it up. Yeah, not exactly wanting to go, so we're going to go press it on. We've got our oil and the gears at 400 degrees. We'll see if that's going to help us out any. Let's go to the press and finish it out. Yeah, they are just not wanting to go on there like I was planning on it. So it looks like they need a little bit more clearance actually, but we got them going. 2 more to go. So again, it was, you saw there, it was really trying to go on there. And I did bump it all the way down to the end, but I went to the press just to be sure because I didn't stop to look to see if the shoulder was all the way up together there. So I think we're finally starting to get the gears to the temperature they need to be with enough thermal expansion for them to go on there. But I still think that key is what's kind of giving me the problem of getting it to slide down the way it should. All right, so we got 2 more of these to do, the smaller diameter. Don't know what to expect. Let's see if they'll drop on. Not a chance. Wow. All right, let's see if we can go press it on. Got it on there. It pressed on nice too. I just don't think I'm getting enough thermal expansion on the gears. They need to be a little bit hotter, but it is what it is. We got 1 more to do. Look at that. Last one, we got success. Wow. The last one was the ticket right there. How funny is that? That is what I was expecting all of them to do. At least we got 1 out of 6. We'll let these guys finish cooling off. We're set up in our KBC knee mill. Already centered the axis of the positioner right here, and I got this to where it kind of floats around. We've got a 4.2 millimeter drill bit. I'm just going to line up this set screw hole. And all we want is just a little dimple in there. It's not going to take much. Just about the diameter of the screw. I'm just looking down from the top. That looks pretty good. Yep. All right. There's 2 of them on here, so I'm just going to crack it loose. Just enough to where it spins and rotates here. Just let the drill kind of line it up there. All right. You want to take it easy at first and let the tip of that drill try to get centered and started. All right. I just drill a little and look in there. You just want it to be about the same size of the hole there. So that's one done. All right, a few more to go. All right, we've got we got these two that we need to dimple. This is a smaller set screw. I believe it's a 4mm. So it looks like a 3.4 through hole or tap size hole. So this was our 4.2. Put that one back, and then here's a 3.4 right here. It's a little snug going in there, a little tight. Let's try 3.3. Come on, I'm trying to grab both of them there. Yeah, that's fitting in there good. 3.3 drill. Dropping it all over the place. So we use that right there. I love this set of metric drill bits right there. This is my Chicago Latrobe part number 57727. It's a really handy set of drills to have around here, especially for stuff like this. Instead of having every 10th millimeter and it's skipping a bunch of sizes, this is a really handy set to have for stuff like this. We are just about at the end of the road for this little project right here. I'm going to go ahead and get these set screws reinstalled in the gears. Looks good right there. Go ahead and do that to the we'll do that to the other three of the helical gear. We'll go ahead and get these smaller set screws installed in this guy right here. Yeah, that looks good. Well guys, this project is getting wrapped up here. We have successfully completed our 6 pinion shafts, and I learned a lot on this job. I literally did learn a lot, and I still have a lot more to learn. But this was a project that I selected from the beginning and said that I think that this would really be a good training exercise for me, using the CNC machines to learn how to program it to make little parts like this for you, versus going over to the manual lathe and doing this, which is what I've always done, and we could have certainly done that way. But this allowed me to kind of go in there and play with our conversational programming and pick up a little bit more on that, so that every time I go over to those machines and want to work on a job or a project, I'm that much further ahead. I just got to keep doing it so that I remember, because it really is easy to forget how to go over there and use the programming. So I think everything turned out well. I know what I need to improve on. You know, I need a few more cutters. I need to invest in some more end mills. I need a collet to hold a couple more of the smaller end mills for the milling machine. So I'm going to get that stuff and so that I have it right here. But learning how to get your tools set to a size over on the CNC mill was interesting, and it's very rewarding when you can take a tool and watch the machine do all the cuts, come in here and mic it, and you're within a couple of tenths to the size that you wanted it to be. That is a very rewarding feeling whenever you actually nail it and you hit your mark there. So I think our interference for our gears can be adjusted a little bit so that they're not so tight going on there. And if we end up doing some more of these, I will continue playing with that so that we can get, we may end up going to like try to shoot for, say, a metal to metal fit, or maybe even like a tenth difference between the two, between the bore and the shaft. But we'll cross that bridge whenever we get there. As I said, it was a really good training exercise. I'm not charging them the time that I've got in learning how to make these parts. You know, this was for me to help further my CNC education, and I really enjoyed that, and you know, getting the gears put on there and all. So anyway, hopefully you enjoyed watching this as part of my little learning journey into trying some new things, and I hope these work out well for them. We're going to send these back. I'm sure they'll get them installed, and they'll let me know how it works, if these are going to work out, and I don't see why they wouldn't. You know, when we talked about at the beginning, I had asked, is, you know, the difference in the width of the gear make any difference there? And they said, no, this doesn't matter, because this is just out there. There's clearance for that, so that's not going to matter. The main thing was, you know, this distance right here is going to be maintained, which it is, and the same thing with the straight tooth gear. That extra, or on this one, being it more narrow, it's not gonna hurt anything there. So this job is complete, and I'm gonna wrap this up. I hope you enjoyed watching. And if we end up doing some batch work of these, I'll give you a little highlight of that if we get into that. But other than that, we'll see you back here on the next project. Hey guys, today I'm working on a couple of shop improvement projects, and I wanted to share with you what it is I'm doing. Making a modification to the top of this roll around toolbox here, and I'll show you a little bit of that. We'll get to that here in just a minute, but I want to start over there at the Miltronic CNC and show you some additional lighting that I just put on there. It's a very simple concept that I've used for many years, and it was the easiest thing that I could come up with that actually was not very expensive, should I say. And maybe I can get some ideas from you guys if you guys have any suggestions to throw at me as far as lighting goes. It's one of the areas that I don't really have a whole lot of knowledge on when it comes to modern day lighting electronics, besides LED. Everybody's going to LED for good reason. But let me walk you over there and show you a couple things that I'm talking about. So I added these clip lights today. All right, and the main reason I'm trying to add lighting is not because me or anybody is standing here operating this machine because you can't see it. It's actually for sharing video with you guys. One of the things that I learned a long time ago is that these kind of LED lights right here, that work light, is not good for video work. Now, it's fine for giving you light so you can see what you're doing in here, but if you're trying to take photos and videos, that cool white light that it comes on every machine tool does not work well. You got to have warm lighting. That's what I've always tried to use, and that's what works well. Even a mixture of the two. But I have noticed in all the videos where I'm showing some milling over here in the Miltronics that anytime you're focused and that light is shining down, especially on coolant, it just blows out the video. I've tried to make simple adjustments with the camera before I take the video to see if anything helps, and the truth is that light just doesn't work too well with video. Now, they added these up here as well. You can see you got one there and up there, but that's the same kind of lighting. So I just added these clip lights. This is something I've been needing to do for a while, and I buy these bulbs right here. This is my favorite light bulb to use, whether it be for this stuff right here or at home. I don't like that blue whitish LED light, so it's the Relax soft white. Now these are the 100-watt bulbs. I got those to try to put as much light in the machine as I can. So pick these up at Lowe's. These are a lot more expensive than they used to be. You used to be able to get these for a few bucks, and now they're I think it was around $8 or $10 a piece for those clip-on lights. Plus the light bulbs are expensive too. So anyway, that worked out good, attaching to the top of the enclosure. I've got the extension cords draped back on the back of the machine, plugged into the Realcraft cord reel over there. So I can easily just get them out the way if I want to take one of these to another machine and use somewhere else. So anyway, I wanted to share this. Hopefully this is going to help with some future work. on the mill here where it's not blowing out the video so bad. But if you guys have any suggestions on some modern day lights that you can use warm lighting, maybe you can adjust the lumens, or I'm sorry, the Kelvin, the color of the light to a warm light, that would be preferred. I don't know if lights like these, you know, you can get them, you know, in different color of the light, but it'd be nice if you could see how bright that is. I can tell from the video, it just blows it out. Now when you do it with the, you see it kind of adjusts a little bit with that one there. But anyway, if you have any suggestions on lights like this that are made for coolant and liquids and stuff like that, send it to my email and let me know. But for now, we're going to be using the clip light. One of the other things that I had mentioned, I think I had mentioned this on Instagram, whenever I was getting ready to fill the sump here with all fresh coolant, the whey oil had drained down into the pan there, so I had to clean that out. It's a problem that everybody has to deal with. The whey lube, it does a really good job of lubing all the ways. And of course, it drips down into the coolant sump right there, and you have to, most people are running skimmers. That's something that I want to see about adding as an oil skimmer to this machine, and that's something we'll get to in the near future, hopefully. But when I was cleaning this out, I made the comment about it would be nice to kind of make an adjustment on the whey lube pump to pump less lube in there. Most people thought that that's the wrong idea. Just let the machine run the way it is. I'm sure Miltronics will agree. No messing with it. I know you can, on some machines, you can actually control the cycle time of the pump to increase it so it's not pumping as often during the day. You can see my whey lube pump right there, the reservoir and the pump. One of the things that Steve at Miltronics showed me, a little tip to try to help battle that, is anytime the machine is on, it's ready to operate, but you're not actually using it. Like whenever he was here, I had both machines on and we were kind of bouncing between the two, doing some of our projects. A little tip that he gave me, he says if you're not using the machine, come over here and just activate the e-stop. You'll get the little red message box there, emergency e-stop pushed. Now he says that when you do this, it deactivates the whey lube pump so it doesn't constantly pump oil. So that right there was a good tip on how to save whey lube. And he says the same thing for the lathe as well. If I have it on, not using it, want to walk away for a bit, just hit the e-stop. That pump will stop pumping whey lube up onto the ways, wasting oil when it's not needed. So I don't know if this is the same for other CNC machines, but it's definitely for the Miltronics. And it doesn't mess up the home position either. Once you come over here and disable it, or let's say enable, it just goes right back into where you were at. You don't have to rehome it or anything. So enable the e-stop when you're not using it to save on whey lube. So I wanted to share that. Thanks, Steve, for that little tip. That's going to help us out there. And hopefully these new little inexpensive clip lights are going to help out with some of the video. So I've got two of these US General roll around tool chests we use. And something I've been wanting to do for a while is add a heavier steel top to this guy right here, because I love the box. I think they work really well. And most people will agree with me. This is a really good value for what you get. Really nice built toolboxes. But the top is a little flimsy, you know. If you start setting things up there, it kind of starts bowing in the middle a little bit. So I want to add a steel plate. So that's what I'm doing today. I had D&D shear this plate for me, and I'm getting ready to do some drilling and tapping. So this is a 1/4-inch plate. And what I wanted to do was go ahead, I'm going to add this Cat 40 tool fixture here. And I've got the Cat 50 tool fixture that I want to bolt on right there. So this will be on this side of the toolbox. They'll be sitting right here. And that'll get those off. I've been clamping these up in the milling machine when I want to use them. And this is the idea that I had for getting these up out of my way. So we're going to do that. I've already got them transfer punched, and we'll use the little mag drill there to drill them and tap them. I'll show you a little video of that whenever we get to it. As far as the steel plate goes, if any of you guys have the same size roller chest and it might be something you're interested in, I wrote down the dimensions. I believe this is considered a 56-inch long tool chest. And when I had Joe shear it up, this is the dimensions. I can't remember, this was a few months ago that I gave him this dimension. So 21 5/8 wide, 56 1/4 long, and that's what he had sheared it to. But it really needs to be 56 1/8 there. So it was a little bit too long. So I ended up setting it up with the, I used an angle grinder and a flap wheel and just dressed, it was actually this side that I just dressed off. And I ended up getting mine 56 3/16 and was able to just kind of bump it down in there. You can see a little paint rub right there, but that'll be fine. So I would like to get another one sheared up for that chest as well. And then that should be a good dimension. If you can get them to shear or burn that exact size, it should drop right on there. And I'm using 1/4-inch thick plate. I would have liked to use maybe some 3/8, but I was afraid that by the time you put the rubber back on here, it's going to be sticking up over this lip here. So I'm going to go 1/4-inch for this one. And if that works out well, I may just have the same thing sheared up for the red tool chest there as well. So I'm going to get these guys drilled and tapped and get this little project finished up. Just using the tip of the tap there to line up the punch mark. And since this mag drill doesn't actually have a reverse on there, we'll just bump it in there until it cuts it, and I'll unchuck it and have to unscrew it. One thing I forgot is my earplugs. I don't like the noise these things make. Earplugs for me. When you're standing right here at the top of this motor, that's where all the sounds just blow right up in your ears. That's the cutting fluid I'm using right there. CRC cutting oil. Come on. Trying to be gentle on the trigger there. Let's see if we can just bump it in. And not tight enough. There we go. Just move that off out of the way. Well, it'll work. At least get the job done anyway. I wish that it had a reverse switch on there like my Black & Decker dad's mag drill has, but that is at the home shop, so I'm going to use what I have here. All right, that project turned out pretty good and finally completed. I think this is going to work out pretty good. I opted for this side of the toolbox because this is away from any of the machines. It's kind of out in the open right there, so I think it'll work out good. So now we've got a good place for our 40 taper fixture holder, and of course we've got our 50 taper as well. So if I want to come over here and tighten that up, or if we got some new ones that we need to put some retention knobs on, whatever, putting the tools in, that's going to work out pretty good. So I'm glad these are finally fixed somewhere, and hopefully the box itself is going to be good enough. It's probably going to try to move and bounce a little bit whenever you tighten on it, but as far as counterweight, I think the box is going to be plenty heavy enough, and I'll show you why. Not only the weight of the plate right there, but the bottom drawer is where I've got all of my multi-fix tools right there for the pacemaker. So those things are pretty heavy, so all those combined in there adds quite a bit of counterweight down here to the bottom of the toolbox. Plus I've got a few other drills and things in there also. All right, so one little shop project finally checked off my my want list, getting these things mounted up there. So I plan on doing the same thing to the red box there as well. It's kind of a mess right now, but I want to get the steel plate up here, and what I want to do is mount a small bench vise to this corner right here, just for holding different things. I want to put a small reed, like a reed 203 or 203.5 right here. I've got one mounted on my workbench there at the home shop, and it's actually, of all my vices that I use in the shop, it's one of my most favorite ones, just because of its small, nimble, handy size and the smooth jaws. If you've got work pieces that you're working on machining that you don't want to mar up with serrated jaws, it's an excellent vise to use for that, to clamp in there if you got to do some deburring or file in or whatever you need to do. I've actually got one that I brought down here that I plan on mounting up here. Let me pull it out and I'll show you what I'm talking about. So this is the vise that I brought down here when I first moved in here, with the intentions on getting it mounted. I never have, but this is where I would like to put it, somewhere right in here. And see, the other reason why I need a steel plate in there, not just for mounting it up, I need to get it up over that lip right there so that I can clear the chin on the bottom of it a little bit. But this is a Reed 103. This is the size I'm talking about. My favorite is either the 203 or 203.5. The smooth jaws is what I would prefer, and this one's a serrated jaws. This is actually a really clean vise. It's just old and it's got a lot of surface rust on it. Just needs to be taken apart and cleaned is all. I think what I'm going to do with this is actually mount it in the milling machine and machine these smooth, because that's how I want to use it. And I've been trying to find another smooth jaw, and they're just getting really hard to find. So many people collect these things now, and I haven't found another one. So I think we're just going to make this a smooth jaw vise, and I'm not worried about it because it's my vise and that's how I want to use it, and I'm going to be putting it to work anyway. So we'll get another plate mounted. I'm sorry, another plate cut for this toolbox here. I'll get it drilled and tapped. Now, doing this this black toolbox and getting it mounted up here, and now that I can kind of see how it's looking, I measured this, and you've got a good at least an 1/8 of an inch there, maybe just a little over 1/8 of an inch left on this lip right here. So I really think that you can at least go to a 5/16 thick plate, but I really think a 3/8 plate would probably be even more ideal for the top of these boxes here. So I believe that's what I'm going to do. The only downfall of that is that you may, if you go to a 3/8, you may end up losing that edge, and that is handy for just keeping things from rolling or getting pushed off of the box. So that's something that we have to keep in mind there as well. So I don't know, I haven't decided yet, but we're definitely going to go with a thicker plate over on the red box so we can get our little bench vise mounted. So that'll be another shop project for another day, and I'll share that with you guys whenever we do it. So one little project finally checked off my want to do list.